The scatter plot, or graph, is similar to line graphs. The difference is that the data is not connected through a continuous line, but represented in single dots. In statistics, scatter plots are used to visualize the data to verify if two variables are related to each other. If, for example, the data points align in a straight line, the graph can suggest a linear relationship. For the scatter plot, go on Insert and then select the Scatter Plot option. Do a right click and click Select Data. Click on Add. First, enter a series name. This is specifically important when you have multiple data series. For now, it will just be the title of our scatter plot. Next, you select the X values and the Y values. They are standard set to 1. Next, you need to format the axis by double-clicking on the axis. Here you can enter the minimum and maximum value as needed, in this case 1 to 13. The same works for the y-axis, double-clicking on it and entering the values as needed. 10 as the lowest in this case. Now, we're just missing the axis labels. Go to Add Chart Element and select Axis Labels, a horizontal and a vertical one. You can insert the text as labeled on our columns. So the age for the x-axis, don't forget the unit in years. And here, the weight in kilograms.
Error bars can be added to all 2D graphs, for example line graphs, scatter plots, and column charts, in order to visualize the margins of error. You can add 4 different types of error bars within Excel.
To insert error bars in Excel, you select your data and go to Add Chart Element, select the error bars. There are different options like standard error percentage or standard deviation. We go here with the standard error. It needs to be further formatted, so you double-click on the error bars. The side window opens first for the horizontal error bars. We don't need them, so we set it to 0. Next, we want to work on the vertical error bars, so we select it here. Here the same options apply. We can first select the standard error that we have used for now, or we insert the standard deviation. This does not make sense in this dataset as we have not multiple values. Or we set a percentage. As you can see, we have first a small error here and a large one in the end. Or a fixed value can be displayed like 0.1. You can do the same with the custom function, just that there you can insert a different value for the error to the upper part and to the lower part. To quantify a trend observed within a dataset, trendlines are used. The algorithm computing a trend line or regression line for a given dataset works always in a similar fashion. Easiest to understand is this for a straight line fit, using the least square fit method. The program assumes a straight line with the standard line equation y equals mx plus b. Now it aims to minimize the distance between the curve computed and the data points, meaning the deviation of the curve from the real data for any given x. For this y deviation, it should not matter in which direction the deviation is happening, meaning if positive or negative distances are computed. Therefore, the following distance equation is formed, with y hat denoting the y value of the fitted line. Therefore, the following equation is formed. Squaring the distance d makes the direction of the deviation irrelevant and makes large deviations contribute more than the small ones. Upon inserting the standard line equation for y hat, only m and b, the values we want to know, and xi and yi, so the data points, are left. by taking the first derivatives of the function s and equating them to 0, so finding the minimum, the values for m and b can be computed and are inserted into the standard line equation. This gives the function displayed by Excel. For functions of higher degree and exponential functions, the system relies on the same methodology, minimizing s, the squares of all distances, but the math to solve such functions is more complicated and mainly relying on matrices. To insert a trend line, you take the scatter plot and select a point on the dataset to which you want to fit the line. Do a right click and select Add Trend Line. Now you have obtained a trend line and it is displayed, but you have not gained information about it yet. You need its equation and the Pearson correlation coefficient. To see both of those, you will have to select the tick boxes. They appear as a text box within the diagram and you can just move them around freely. Sometimes you need to try and find the function that maximizes the r² value, so most accurately represents your data. If you select the polynomial, you need to, beside just ticking the box, also select the degree, which most accurately will represent your data. The degree is the highest exponent in the displayed function. A power function does not accurately represent our data, we will turn back to the exponential one. Further settings are that you can extend the trend line over your dataset using the forecast function. Insert any value in forward or backward direction to elongate your trend line. Also, you can set an intercept, so the value for x equals 0, if you know the respective y value. This can in some context be relevant, as a certain starting value is safely known and it contributes to the accuracy. Another option for adding a trend line is to select the dataset and go to Add Chart Element, and select the trend line here. Here you have still the options, and we select the exponential one. For further settings, you double-click and will find yourself in the same window as you have seen before. Further important for trend lines is to change the color, which you can do here.